So today's lecture, we're going to start with the Sturm Liouville problems. Now, basically, when we talk about Sturm Liouville problems, these are boundary value problems. Okay, and okay, before I start with the lecture, last three lectures I had to put it on YouTube because it was showing the recording is very large and it was not taking it on the LMS platform. So then I had to put it on YouTube and then I had to share the link over there. I hope that was convenient for everyone.
Ma'am, that was very convenient, ma'am, to go through
Okay.
the YouTube. It was very convenient.
Okay, because I don't know, it was not taking the entire lecture uploading. I tried twice, thrice, but then it was not taking it. Was saying that the file size is very big.
Even if we get the upcoming videos in the YouTube, it will be far better, ma'am.
Okay, fine. Yeah, I'll try that. Okay, not an issue. Yeah. So we are starting with the Sturm Liouville problems. The Sturm Liouville problems, as I said, are boundary value problems. Now, what is the difference between boundary value problems and initial value problems? Anyone? We have discussed this before. What is the difference between initial value problems and boundary value problems? Anyone? Come on. Give it a try at least. I believe first introductory lecture जो था ODE का जहाँ पे मैंने revision लिया था वहाँ पे I had discussed this. No one?
And if the value is known at only one particular point, then it is initial value problem.
Very good. Very good. And when we are calculating the value at two different points or multiple points, it is called the boundary value problem.
Boundary value problem.
Yes, very good. So if I have something like, I know the value of y at a point A is some a1 at y dash at a point A is again a2, some constants, okay? बट यहाँ पे ये चीज ध्यान रखनी है कि आपका जो पॉइंट है वो ए ही रहने वाला है एट जीरो. इफ आई एम कैलकुलेटिंग फॉर जीरो इट इज गोना बी जीरो फॉर बोथ. वन पे कैलकुलेट करते दोनों पे वन पे कैलकुलेट करें सेम पॉइंट पे. ओके, जबकि बाउंड्री वाली प्रॉब्लम में डिफरेंस ये होगा एट ए सम c1 and at b some c2. So now you can understand that these points are different. A and B are different points. So this is the difference between the boundary value problem and the initial value problem. We're going to look at a special category of boundary value problems that is called the Sturm Liouville problems. Okay, we'll first understand the definition, then we'll see how to convert the standard Basel's equations or Legendre's equation into the Sturm Liouville problem. We'll also learn the standard method of conversion of any other problem as such into a Sturm Liouville problem. And then we'll study about the eigenvalues and eigenfunctions, which is also a part of unit number 4, and some of the characteristics of eigenvalues and eigenfunctions. Okay, so most probably I'll try to keep this lecture into the introduction part and properties and sums, theorems. Okay, wherever required, we'll try to prove, or else we'll take it into the next lecture, maybe tomorrow, and we'll wind up with the system of ODEs, what is remaining now from my end after this. Okay, so let's begin with the standard form of Sturm Liouville problem. Okay, so we'll start with considering the differential equation of the form dy by dx, sorry, not dy by dx, dy by dx of p of x y dash plus q of x plus lambda times r of x into y equals to 0. I'll call this equation as equation number 1. Here p of x, q of x and r of x are continuous functions. On say maybe the interval a comma b. So this function will also be defined on the interval x belonging to a comma b. And lambda is a constant. Lambda is a constant. this equation number 1 along with the boundary conditions a1 y of a2 y dash of a equal to 0, b1 y of b plus b2 y dash of b equal to 0, where a1 square plus a2 square is not equal to 0 and b1 square plus b2 square is not equal to 0, is called the Sturm Liouville problem. Okay, so let's understand this problem. If you observe equation number 1, you can see it's a second order equation. भले मैंने d by dx लिखा है, बट ये जो d by dx है वो y dash पे भी एप्लीकेबल होगा जब, तो वो सेकेंड ऑर्डर प्रॉब्लम में कन्वर्ट हो जाएगा. तो बेसिकली स्टर्म लियोविल जो प्रॉब्लम है वो सेकेंड ऑर्डर डिफरेंशियल इक्वेशन है. Okay, we have worked a lot on second order differential equation in unit number 2. Fine. And last lecture also, unit number 3, we were working on variable coefficients over there. We learned the method of reduction of order and things like that. Okay. So this is basically a second order differential equation, but the method of writing it is a little different. Okay. Now let's understand what is the eigenvalue, what is the eigenfunction, and then we'll see how to tackle these things. So we talk about lambda over here. We talk about lambda. So this is where linear algebra gets connected with ODE. Okay, this is where linear algebra, this is where, and system of ODE. These are the two places where linear algebra gets connected with ODE. Okay, so the value of lambda for which the Sturm Liouville problem has non-trivial solution. Now, what do you mean by non-trivial solution? Everyone is clear with that? Okay, non-zero solution. Zero solution हमेशा रहेगा because ये homogeneous system है, RHS equal to 0 है. Okay, so zero solution हमेशा इसको satisfy करेगा. Y of x equal to 0 is a trivial solution which will always satisfy. We are interested in the non-zero solution. तो वो values lambda के जो हमको non-trivial solution देंगे इस equation के लिए, okay, that values will be called as eigenvalues. These are called as eigenvalues. Those values of lambda, constant values जो आएंगे वो आपको, okay, उसको eigenvalues कहेंगे. And the corresponding eigen or the corresponding function which we'll get, okay, the corresponding non-trivial solution, जो solution मिलेगा वो एक function के form में होगा, is called the eigenfunction. Is called the eigenfunction. So let's understand this better with the help of an example. Okay. And one more thing you need to note over here, we have written a1 square plus a2 square is not equal to 0. अब a1 और a2 क्या है? रियल नंबर्स है. दोनों का स्क्वायर का एडिशन 0 कब होगा? जब इंडिविजुअली दोनों 0 होंगे. अब जब इंडिविजुअली 0 हो गए तो बाउंड्री वैल्यू कंडीशन एग्जिस्ट ही नहीं करेगा, क्योंकि a1 a2 दोनों अगर 0 हो गए तो बाउंड्री वैल्यू कंडीशन नहीं बचेगा. सो दिस इज समथिंग वेरी लॉजिकली रिटन देयर कि a1 स्क्वायर प्लस a2 स्क्वायर इज नॉट इक्वल टू 0. तो यहाँ पे a1 a2 दोनों इक्वल टू 0 नहीं होने चाहिए. सेम वे b1 b2 दोनों इक्वल टू 0 साइमल्टेनियसली नहीं होना चाहिए. ठीक है. ओके. सो इसमें किस तरह के क्वेश्चंस आ सकते हैं एंड व्हाट आर वी एक्सपेक्टेड और व्हाट आर वी ट्राई टू अंडरस्टैंड दिस विद द हेल्प ऑफ एन एग्जांपल. ठीक है. सो द क्वेश्चन सेज फाइंड द आइगन वैल्यूज and eigenfunctions. I'm using short forms, okay, of the differential equation y double dash plus lambda y equal to 0 for all x in the interval 0 to L, and the boundary condition given to us is y of 0 is equal to y dash of L is equal to 0, okay, for L greater than 0. So this is one of the questions, and while solving the question we'll understand Sturm Liouville problem much more better. So your basic thing is going to be to find the eigenvalue and eigenvector. That's our target. Okay. So पहले तो is this a Sturm Liouville problem? Yes, students. Is this a Sturm Liouville problem? Is this in the standard form? Yes or no? Sturm Liouville problem का standard form equation number 1 में है. which is visible to you on the screen. Is this the standard form of the Sturm Liouville problem? If yes, what is the value of Px? What is the value of Qx? What is the value of Rx? Yes, students. Anyone? Come on. Is it Sturm Liouville? You want me to explain?
Yes, ma'am.
Okay. Chalo. So what do we do here is, suppose if I take P of x is equal to equal to 1. If I take P of x is equal to 1, Q of x is equal to 0 and R of x is equal to 1. इक्वेशन नंबर 1 में अगर मैंने ये वाली वैल्यूज डाल दी एंड ऑब्जर्व ये सारे के सारे कंटिन्यूअस फंक्शंस है, करेक्ट नो? कांस्टेंट फंक्शंस है, सारे के सारे कंटिन्यूअस है. P of x is equal to 1, Q of x is equal to 0 and R of x is equal to 1. आपका कंडीशन क्या कहता है? P of x, R of x and Q of x should be continuous functions on the given interval. तो ये हमेशा कंटिन्यूअस रहने वाले हैं. If I do that, will equation 1 get converted to the question equation? आपके पास क्या बचेगा? d by dx of y dash, क्योंकि P of x की वैल्यू 1 है, प्लस 0 plus lambda into R of x की जगह पे 1 y. Is this going to give you the equation which we are dealing with right now?
Yes, ma'am.
Okay. So this is how you need to identify P, Q and R. Of course, we'll learn the normal method also. We'll learn the different method as well. Okay, कैसे convert करना है, क्या करना है. But right now, I hope you have understood that this question is what we're dealing with is a Sturm Liouville problem. And यहाँ पे जो boundary conditions दी है, ओके, तो फर्स्ट बाउंड्री कंडीशन अगर आप फर्स्ट बाउंड्री कंडीशन के साथ कंपेयर करोगे तो A1 की वैल्यू 1 है यहाँ पे एंड A2 की वैल्यू 0 है. हमको बोला है दोनों साइमल्टेनियसली 0 नहीं होने चाहिए, तो दोनों साइमल्टेनियसली 0 नहीं हुए हैं. एंड सेकंड कंडीशन में देखोगे तो B1 की वैल्यू 0 है, B2 की वैल्यू 1 है. ओके, so that's the boundary condition also. So this is exactly a Sturm Liouville problem with different values for P, Q, R, A1, A2, B1, B2. Okay. So once we've got this, we need to learn how to solve this Sturm Liouville problem. So what is our target going to be? Your target is going to be to find the eigenvalues and eigen functions. यही बोला है. तो eigenvalues क्या है? जो हमको नॉन ट्रिवियल सॉल्यूशंस देंगे. ठीक है, तो लैम्बडा की वो वैल्यूज ढूंढनी है जो हमको नॉन ट्रिवियल सॉल्यूशंस देंगे. कैसे ढूंढेंगे? चलो 3 केसेस में इसको डिवाइड करेंगे हम. Case number 1, we assume that lambda is greater than 0. Okay, lambda is positive. So if lambda is positive, I would assume let lambda is equal to some nu square. Okay, where nu is not equal to 0. So let's call this as equation number 1 for this particular question. Okay, and let's substitute it there. So I'll get y double dash plus nu square y equal to 0. This is a second order differential equation. मुझे इसको solve करना है second order differential equation को. So yeah, let's solve this second order differential equation. Anyone on how to solve this differential equation? Come on. सेकेंड ऑर्डर डिफरेंशियल इक्वेशन को कैसे सॉल्व करेंगे? इसका ऑक्सिलरी इक्वेशन आएगा m स्क्वायर प्लस न्यू स्क्वायर इक्वल टू 0. करेक्ट है ना? तो m स्क्वायर इक्वल टू नेगेटिव न्यू स्क्वायर हो जाएगा, मतलब m की वैल्यू हो जाएगी प्लस और माइनस न्यू आई. इज इज ओके? कॉम्प्लेक्स रूट्स आ गए हैं. कॉम्प्लेक्स रूट्स आए तो सोल्यूशंस क्या होंगे? y इज इक्वल टू c1, सॉरी, लाउडर, लाउडर प्लीज, लिटिल लाउडर, इट्स ओके.
E raised to mx.
No, why would we go for e?
A cos
Correct. c1
A
cos
cos
nu x,
E cos
c2 sin nu x. Correct, no? E raised to mx is used, of course, but then we have learned, no, वो e raised to mx को sin and cos में कैसे convert होगा. Okay, so we'll not go through all that steps again. Fine. E raised to mx वाला जो method है वो correct है, but then with complex numbers it breaks down into cos and sin, and e raised to mx you are now continuing to use only for real roots. Okay, for real roots. Okay, so we got these roots. Our target is to find those values which will give you non-trivial solutions. This is your y of x, I can say. There are some boundary value conditions. Let's use those boundary value conditions. So the first boundary value condition is y of 0 is equal to 0. So let me substitute 0 in place of x. So I'll have 0 in the left hand side because that's y of 0. Right hand side will be leaving me with c1, right? Cos 0 is 1 and sin 0 0 हो जाएगा. So इसका मतलब ये हुआ कि c1 is equal to 0 हो गया. Okay. Second condition, I have y dash. Okay, so let me first calculate y dash. डेरिवेटिव निकालेंगे इस इक्वेशन का. लेट मी कॉल दिस इक्वेशन 2. इक्वेशन नंबर 2 का डेरिवेटिव कैलकुलेट करते हैं. सो व्हाट्स द डेरिवेटिव ऑफ इक्वेशन नंबर 2? इट्स गोना बी c1 negative c1 nu sin nu x plus c2 nu cos nu x. Is that correct? Okay. So we got these derivatives and I already know c1 is 0. So I will be left with only c2 nu cos nu x. Okay, ये आपका y dash of x हो गया. अब ये जो y dash of x है इसमें हम बाउंड्री कंडीशन डालेंगे. हमारे पास y dash of l is equal to 0 दिया है. So since y dash of l is equal to 0, I'll substitute x की जगह पे l. So I'll be left with y dash of l which is equal to 0 and यहाँ पे c2 nu cos nu l हो जाएगा. Okay. Now we are looking for non-trivial solution. हमको non-trivial चाहिए solution. तो यहाँ पे दो terms का multiplication. Okay. One more thing, यहाँ पे let's understand nu is not equal to 0 दिया है. So I would write c2 cos nu l is 0 because nu से divide कर सकते हैं. Now I have product of two terms, 1 and 2. Product is 0. If I want non-trivial solution, okay, c2 0 हो जाएगा तो trivial हो जाएगा ना solution. Equation 2 में अगर c2 और c1 दोनों 0 डालोगे तो y of x is equal to 0 बचेगा, मतलब trivial solution हो जाएगा. For non-trivial solution, c2 is not equal to 0, which implies cos of nu l will be equal to 0. Cos की value 0 कब होती है? Yes, please. When is cos value equal to 0? For which angles?
Pi by 2.
Pi by?
Pi by 2.
Odd pi by 2. Not only pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, all the odd pi by 2s. Okay, fine. So this is going to be equal to, this implies cos nu l would be equal to 2n plus 1 pi by, okay, sorry, cos should also come in here. Or I can just remove this and say, yeah, then the angle is 2n plus 1 times pi by 2, where n belongs to whole numbers. N is equal to 0 से start होगा. Okay, so n will belong to whole numbers. Yeah. So in this case, your target is to find nu because आपको lambda ढूंढना है. Lambda is dependent on nu. So I would say nu is equal to 2n plus 1 pi by 2l. Your lambda was equal to nu square. Okay. 1 minute. Okay. Yeah. So lambda was equal to nu square. So we'll be squaring this. So we'll get the first eigenvalue. The first set of eigenvalues here is lambda equal to 2n plus 1 the whole square pi square by 4l square. Okay. तो यहाँ पे होल नंबर्स नहीं लिखेंगे, यहाँ पे हम z लिखेंगे क्योंकि इंटीजर्स में से नेगेटिव वैल्यूज भी आ सकते हैं. एंड यहाँ पे हम लिखेंगे होल नंबर्स बिकॉज या स्क्वायरिंग करने के बाद तो आंसर पॉजिटिव ही बचने वाला है. सो दीज आर वन सेट ऑफ आइगन वैल्यूज विच यू गॉट. जैसे जैसे आप n की वैल्यू चेंज करते जाओगे यू विल कीप गेटिंग डिफरेंट आइगन वैल्यूज हियर. So this is one set of eigenvalues and correspondingly you will keep getting different eigenfunctions. So let's look at the eigenfunctions also because question is about eigenfunctions as well. And this is just case one which we are doing. So what is the corresponding eigenfunction? Your corresponding eigenfunction is y of x. Y of x we are left with in equation 2 c1 is 0, c2 डालेंगे, c2 sin nu x है. So c2 sin, the value of nu x is given by 2n plus 1 pi x upon 2n. Okay, so this is going to be the entire angle for sine. So these are your set of eigenfunctions. So यहाँ पे when I say functions, why am I saying plural? Because जैसे जैसे c की value भी change करोगे, you will get different values, and as you change n also, you will keep getting different values. Okay, I hope. How did you find the eigenvalue and eigenfunction is clear with this part? Is case 1 clear? कोई doubts है? Anyone? Yes, please.
No, ma'am.
Okay, fine. So let's look at case 2 and case 3. So what's going to be case 2? चलो case 2 क्या होगा? हमने पहला केस लिया था लैम्बडा ग्रेटर देन 0 ना. So what will be case 2? Yes, students. Lambda equal to 0 ले लेते हैं. We can take lambda less than also. Let's take lambda equal to 0. फिर case 3 में less than ले लेंगे. No problem. Okay. So lambda equal to 0 ले लिया हमने. So lambda equal to 0, if I put it in the differential equation of the question, equation number 1, y double dash plus lambda y equal to 0. Lambda की जगह 0 डाल दिया तो मुझे क्या मिलेगा यहाँ पे? I'll get y double dash is equal to 0 because the second term will become 0. इसका ऑक्सिलरी इक्वेशन हो जाएगा m स्क्वायर इज 0, तो m के दो रिपीटेड रूट्स आएंगे 0,0. सो आपका y ऑफ x क्या होगा? रिपीटेड रूट्स में क्या आता है? यस प्लीज. Will it be c1 plus c2x into e raised to 0x, which will become c1 plus c2x? Is that okay? I'll call this as equation number 3. Okay, again your target is to find c1 and c2 using the boundary condition. First boundary condition was y of 0 is equal to 0. So x की जगह पे 0 डालोगे जब आप, तो c1 equal to 0 हो जाएगा, which implies y of x is only left with c2x. Y of x is left with c2x. Okay, अब y dash calculate कर लो. So वहाँ पे c2 बचेगा. Y dash at L is given to you as 0. So c2 की वैल्यू भी 0 हो गई. इसका मतलब क्या हुआ? This implies the y of x from equation 3 is nothing but 0, which is a trivial solution. We are interested in non-trivial solution because non-trivial solution पे eigenvalues and eigenfunctions मिलते हैं. Okay, so case number 2 में मुझे कोई eigenvalue, कोई eigenfunction नहीं मिला है. Let's work on case number 3 now. Case number 3 में lambda less than 0 लेंगे. Lambda less than 0 है तो उसको हम assume करेंगे lambda is equal to negative mu square. Okay, जो nu का square है, मतलब nu कोई real number है, तो उसका जो square होगा वो obviously positive होगा, but minus लगा देंगे तो वो lambda की value negative हो जाएगी. So my first equation y double dash, the given differential equation y double dash plus lambda y equal to 0, उसमें lambda की जगह minus mu square डालेंगे. So from equation number 1 I'll get y double dash minus mu square y equal to 0. Auxiliary equation would be m square minus mu square equal to 0. M square is equal to mu square, so m is equal to plus or minus nu, when nu is a real number. Okay, so you will be now getting c1 e raised to mu x plus c2 e raised to negative mu x. Okay, so this is where someone said this answer before, but then I said it was not correct that time. That was for complex numbers. In real numbers, you write it like this. Okay, so we got y of x here. Now let's again apply the boundary condition. First boundary condition, y of 0 is equal to 0. So let's replace by 0. I will get c1 plus c2 is equal to 0. Is that correct? Okay, and when I take the derivative, y dash of x, so I'll be left with c1 nu e raised to nu x minus c2 nu e raised to negative nu x. And I'll apply the boundary condition y dash at L is equal to 0. So we'll have c1 nu e raised to nu L, c2 nu e raised to negative nu L is equal to 0. Nu is not equal to 0. So let's divide by nu. So c1 e raised to nu L minus c2 e raised to negative nu L is equal to 0. अब ये जो दो इक्वेशंस मिले हैं, लेट मी कॉल दिस एज इक्वेशन 5, लेट मी कॉल दिस एज इक्वेशन 6, इन दोनों को हमको सॉल्व करना है. ठीक है, तो ये लीनियर सिस्टम ऑफ इक्वेशंस हो गए हैं होमोजीनियस वाले. These are homogeneous linear system of equations. Homogeneous linear system of equation के बारे में क्या पता है आपको? Yes, please. This homogeneous system will always have a trivial solution. मतलब C1 इक्वल टू 0, C2 इक्वल टू 0 डाल दो तो दोनों इक्वेशन सेटिस्फाई हो जाएंगे ना, इक्वेशन 5 एंड 6 हमेशा। होमोजेनस सिस्टम की यही खासियत होती है कि उसमें आप 0 0 सब्सटीट्यूट कर दो वेरिएबल्स की जगह पे, तो आपको हमेशा आंसर RHS इक्वल हो जाता है। यस और नो? ओके, सो इफ दैट्स वर्किंग आउट हियर, लाइक C1 C2 अगर 0 0 डाल दिए मैंने, तो दिस इज गोना बिकम लाइक होमोजेनियस सिस्टम जिसका ट्रिवियल आंसर आएगा। वी आर नॉट इंटरेस्टेड इन ट्रिवियल आंसर। सो नॉन ट्रिवियल आंसर कब आएगा? व्हेन आई कन्वर्ट इट इनटू मैट्रिक्स, I can write it as 1 1 e raised to nu l negative e raised to nu l into C1 C2 equal to 0 0. Okay, so if the determinant of this matrix is 0, then I will have non-trivial solution. Okay, so if I call this as A, if the determinant of matrix A, if the determinant of matrix A is 0, then equation 5 comma 6 have non-trivial solution. Have non-trivial solution. Is this okay? Okay. So let's see if this determinant will become 0 or no, or if it is non-zero, it will have trivial solution. Okay. And if determinant of this matrix is non-zero, then the system will have trivial solution. So this is the theory which is in linear algebra. So let's calculate determinant of A here. So I'll get negative e raised to nu l and minus e raised to nu l again. So this is negative 2 times e raised to negative nu l. Now this is exponential graph. Does exponential ever become 0? This never becomes 0, so this is never going to be 0. This implies that C1 and C2 together will not be 0. Okay, so this will not be equal to 0 comma 0. Oh, sorry, this will be equal to 0 comma 0. Trivial solution. So this implies y of x is equal to 0. We get only trivial solution. We wanted to find eigenvalues and eigenfunctions. Eigenvalues and eigenfunctions के क्या बारे में क्या बोला था? आइगन वैल्यू वही वैल्यू होती है जहाँ पे नॉन ट्रिवियल सॉल्यूशंस मिलते हैं। सो हमने तीनों केसेस कवर किए हैं। केस नंबर 1 में वी टुक लैम्बडा ग्रेटर देन 0, वहां पे हमको आइगन वैल्यूज एंड आइगन फंक्शन मिले हैं, वी फाउंड देम। लैम्बडा इक्वल टू 0 में ट्रिवियल सॉल्यूशन ही आ रहा था, मतलब आइगन वैल्यू आइगन फंक्शन एग्जिस्ट नहीं कर रहे हैं। लैम्बडा लेस देन 0 में भी आइगन वैल्यूज आइगन फंक्शन एग्जिस्ट नहीं कर रहे हैं। ओके, सो वी गॉट आइगन वैल्यूज एंड आइगन फंक्शंस।
Ma'am,
यस प्लीज।
ma'am, from the last, the third line for the finding the determinants is minus e raised to minus mu l minus e raised to mu l. No.
Okay, mu l, yes. So any which ways it is plus
So we
mu l.
get yes, miss.
Okay, so now again, still after this, will this become equal to 0?
No, I guess it's 1 minus 1. That's
Yeah,
1 or 1.
actually, see, this could have become equal to 0. No, this cannot become equal to 0 because they are any which is negative, both of them. Even if there was like, one positive and one negative, like e raised to x minus e raised to minus x, and thanks for the correction. If we had this also, this becomes equal to 0 only when both of them become equal, like, correct? And when do they both become equal? The graph of e raised to x and e raised to minus x. This is a graph of which one? Yes, please. And this is which graph? This is e raised to minus x and this is e raised to plus x. Okay. So they meet only at the point x is equal to 0. They meet only at the point x is equal to 0. So the values are equal only at the point x is equal to 0. Now for that to be equal, I would have had to have mu l to become equal to 0. So mu l becoming equal to 0 is not possible because mu also is not equal to 0 and L is greater than 0. You observe the question. L is greater than 0 here. You can see it here. And our case 3 where we started, we have very clearly said that mu is not equal to 0. Is that okay with everyone now? So again, this will never be equal to 0. Any difficulties? Yes, please. Is this clear? How to find the eigenvalues and eigenfunctions? Is this fine? Yes, students, I'll give you 1 or 2 questions to try on your own right away. Have you understood this? अगर नहीं समझ में आया कोई भी step तो please ask, or else I'm giving you a question to solve right now on your own. Okay, and then we'll discuss the answer to the same. Shall we proceed to the question?
Yes, ma'am.
Okay, fine. So I want you guys to try this question. Again, the question remains the same. Find the eigenvalues and eigenfunctions for the Sturm Liouville problem. Y double dash plus lambda y equal to 0 with the boundary conditions y of 0 equal to 0 and y of 1 equal to 0. Come on, begin please. Try it, and let's say not more than 10 minutes. Not more than 10 minutes. Actually, I would suggest 5 minutes, okay? Sure. It's 11:50 almost, 49 now, 50. 55 we should be able to discuss the answer.
Ma'am, it's y dash 1 is 0.
Fine. दरवाजा बंद कर. No, the boundary condition is y of 1 equal to 0 itself. The conditions can keep changing, no? Previous one में हमारा b1 0 था, b2 नॉन जीरो था. यहाँ पे b1 नॉन जीरो है, b2 0 हो गया है. It's okay. You have to again divide it into 3 cases like we did before. I think the only difference will come when the boundary conditions change. बाकी सब same आने वाला है. Did anyone find the eigenvalues or eigenfunctions? Is it done? Or you require my help?
Ma'am, in first case, eigenvector is n square pi square.
Eigenvector नहीं, eigenvalue की बात कर रहे हो आप शायद.
Yes, eigenvalue. An eigenvector is C2 sin n pi x. Is it correct?
It's absolutely correct.
Okay.
Yeah, very good. Eigenvalues are n square pi square, where you take lambda greater than 0.
Yes.
And your eigenfunctions are C1 or C2, whatever, C constant.
C1 is 0, C2. Yes.
Yeah, whatever, whichever. No, it depends. No? Someone might have taken C1, C2 ulta.
Okay, ma'am. Okay.
Constant times sin n pi x. What about other people? Have you got it?
Yes, ma'am.
Okay. Does anyone want me to solve this, or shall we move further to the next topic? Yes, class? Do you want me to solve this, or we'll move to the next part? You want me to solve this? Okay, no problem. Okay. Fine. So let's quickly go through this. So again, as we had done it for the previous question, we'll divide this question again into 3 parts, case 1, 2, and 3. So if I start with lambda greater than 0, we would assume lambda is equal to positive nu square when nu is not equal to 0. And let me call this as equation number 1. My equation 1 will now get converted to y double dash plus nu square y equal to 0. Auxiliary equation would be m square plus nu square equal to 0. M square is equal to negative nu square, which gives me m is equal to plus or minus I times nu. Complex roots, so y of x would be equal to c1 times cos nu x plus c2 times sin nu x. Okay, I call this as equation number 2. Now we work on the boundary conditions. So first boundary condition is y of 0 equal to 0. So I replace 0 in place of x over here, and I would get C1 is equal to 0 because cos 0 is 1 and sin 0 is 0. So I'm left with y of x is equal to C2 sin nu x. Now we use second boundary condition, that is y of 1 equal to 0, and we would get 0 is equal to C2 sin nu. Is this correct? And if I get this over here, this means either C2 is 0 or sin nu is 0. Now, because we are interested in non-trivial solutions, so for non-trivial solutions, C2 cannot be 0. So we would take, say, sin nu is 0. If sin nu is 0, we can say sin nu takes 0 values at n pi values, okay, where n is an integer. So I have now nu is equal to n pi. Lambda, which is nu square, will become n square pi square. And when I substitute this value of nu C1, C2 in equation number 2, we would be left with y of x is equal to C2 sin n pi x. Okay, so these are your eigenvalues and these are your eigenfunctions. And I believe if you go for lambda equal to 0 and lambda less than 0, you're not getting any eigenvalues or eigenfunctions there. Is that correct? Did others check case 2 and 3 also? These are the eigenvalues. And these are the eigenfunctions. Did you check case 2 and 3? Say lambda equal to 0. When I put it in equation number 1, I would get y double dash equal to 0. Auxiliary equation is m square equal to 0. So m is 0, 0. Y of x would be c1 plus c2x e raised to 0x is going to give me 1. So y of 0 is 0, which means c1 is 0. And y of 1 is 0 implies c2 is 0. So y of x is equal to 0 is a trivial solution. So no eigenvalues. Now case number 3. Case number 3, which talks about lambda being less than 0. So we start assuming lambda is equal to negative nu square, again where nu is not equal to 0. So y double dash minus nu square y is 0. Auxiliary equation is this. So m would be equal to plus or minus nu, real roots, distinct roots. So c1 e raised to nu x, c2 e raised to negative nu x. Y of 0 is 0. So this means c1 plus c2 is 0. And y of 1 is 0 implies c1 e raised to nu plus c2 e raised to negative nu is 0. Let's take the determinant directly now. C1, C2. Okay, not C1, C2. We're taking determinant of coefficients of C1 and C2. So it's going to be 1, 1. And e raised to nu and e raised to negative nu. So this determinant is e raised to negative nu minus e raised to positive nu. And again, since nu is not equal to 0, this determinant won't be equal to 0. Okay? So I may write this as a reason in the bracket. So therefore, we will always get only trivial solutions. So y of x has trivial solution, or that is, this implies c1 is equal to c2 is equal to 0. So y of x will be equal to 0. Again, only trivial solution. which means no eigenvalues and no eigenvectors. I hope things are clear so far. Case 1, case 2, and case 3. So as the boundary conditions change, your solution changes a little, otherwise the method is going to remain the same. I hope this is clear. Any difficulties? Yes, students? You can just raise your thumbs up or something. How many of you could complete the sum on your own? All the 3 cases? Okay. How many of you could complete at least one case on your own? Okay, fine. No issues. So I hope now everything is clear. We look at another type of boundary conditions now, which are called as periodic boundary conditions. Okay. So the ones which we looked at right now are the normal boundary conditions. And now we're looking at periodic boundary conditions. So let's first understand that and then do maybe a sum based on the periodic boundary conditions. Not much of a difference, just the boundary condition changes. So basically there are 3 types of Sturm Liouville problems. One is the normal boundary condition, which we saw before this, that a1 y at a plus a2 y dash at a equal to 0 and b1 thing. Second, we are looking at periodic, and there is a third one, which is not very common. The questions are not asked in that, or it's not used much. Okay. So what is the periodic boundary condition here? The periodic boundary conditions look something like this. You will have y of a is equal to y of b, and y dash of a is equal to y dash of b. I hope there's no need to explain why the word periodic. The values are repeating after a certain period. After a, at b, again the value is the same. After for derivative also, after a, the value again is the same at b. Okay. So the only difference with periodic conditions and the normal form is, in the normal form, we got only one function there. Okay. As in, यहाँ पे अगर notice करोगे, there is only sign remaining, okay, like sin n pi x. If you look at the previous question, we were left with again sign, okay, not necessarily always sign, but only one function will be remaining. मतलब cos vanishes तो sin बचा, sin vanishes तो cos बचा, एक ही function रहेगा. When we talk about periodic boundary conditions, you will have 2 linearly independent functions remaining. Okay, so that's what is going to happen here. So let's understand this again with the help of an example. The question remains the same. Find the eigenvalues and eigenfunctions of again the same, okay, not exactly the same, of Sturm Liouville problem, y double dash plus lambda square y of x equal to 0. Okay, satisfying the boundary conditions, y of 0 is equal to y of pi, and y dash of 0 is equal to y dash of pi. Come on, give it a start. And let's observe here, instead of lambda, they've given lambda square. So you will only have 2 cases. One is lambda equal to 0 and second is lambda greater than 0. Like greater than or less than, not equal to 0. Because greater than 0 हुआ या less than 0 हुआ, square will always be positive. Correct? So you will have 2 cases only. Case number 1 would be lambda equal to 0 and the case number 2 would be lambda not equal to 0. Because lambda is a real number. Okay? So give it a try and see what are you getting here. Take 5 minutes. Any answers? Yes, please. Is lambda equal to 0 giving you any eigenvalue? लैम्बडा नॉन जीरो पे क्या मिल रहा है? You want me to solve? Or you guys managing on your own? Yes, please.
Ma'am, please explain.
Yeah, definitely. Okay. So let's begin here. As we are expected to do 2 cases only, not 3 cases, because lambda square है question में. ठीक है? So lambda equal to 0 अगर start करेंगे, so my equation number 1, I'll take this. My equation number 1 will get converted into y double dash equal to 0, and auxiliary equation will be this. M will be equal to 0, 0. So my y of x would be equal to C1 plus C2x. I hope everyone has got it so far. No
Yes.
difficulties?
No.
Okay.
Yes,
So
ma'am.
first condition, y of 0 is equal to y of pi. So when I put 0 and pi simultaneously, 0 डालेंगे तो C1 बचेगा left hand side में. And when I put pi here, I'll be left with C1 plus C2 pi. So C1 gets cancelled, okay, because subtraction हो जाएगा. So C2 pi is equal to 0. Pi is non-zero. So C2 is equal to 0. This implies that C2 is equal to 0. And let's take the second condition. Y dash of 0 is equal to y dash at pi. So I'll take derivative of, say, equation number 2. So y dash of x is going to be left with only C2, right? And y dash at 0 is equal to y dash at pi, which implies that C2 is equal to C2, which is like, I'm not getting any answer for C2. Okay, C2 is already 0, no? Okay, C2 is already 0 here. Fine. So I'm left with C1. C1 has no value as of now. If you can observe, C1 has no value as of now. So this means we can get an eigenvalue at 0. C1 can take any values now. It can, means it's not compulsory 0. 0 आता है तो ही हम trivial बोलेंगे. So you're left with y of x is equal to C1. And therefore, lambda equal to 0 is an eigenvalue. And the corresponding eigenfunction, it's actually a group of functions. These are the eigenfunctions. Y of x equal to C1. C1 की जैसे जैसे value change करते जाओगे 1, 2, 3, 4 से maybe root 2, root 3, whatever, you will keep getting different eigenfunctions here. Okay, so you got one set of eigenvalues, one eigenvalue and a set of eigenfunctions there. Okay, so let's now, I hope the first case is clear, lambda equal to 0. And everyone has understood that we cannot find C1 here. The given conditions are not allowing me to find C1 at all. Okay, so this is equal to 0, which we already know. Okay, so let's move on to case 2 now. Case 2 is lambda is not equal to 0. My equation 1 is y double dash plus lambda square y equal to 0, right? That's what my equation, well, yeah, that's what my equation number 1 is. So auxiliary equation m square plus lambda square equal to 0 हो जाएगा. So m square is equal to negative lambda square. So m is equal to plus or minus lambda I. यहाँ पे mu square की जगह lambda square है, okay? So y of x will be equal to your C1 cos lambda x plus C2 sin lambda x. Let me call this as equation 3. आपके पास y of 0 equal to y of pi है. So when I put 0, I will have C1, okay, equal to y of pi. I will be left with C1 cos lambda x, sorry, cos lambda pi plus C2 sin lambda pi. अब इसको 0 नहीं बोल सकते बिकॉज लैम्बडा की वैल्यू क्या है वो पता नहीं. लैम्बडा अगर इंटीजर होता तो ये डेफिनेटली 0 हो जाता या 1 हो जाता. But then we don't know the value of lambda. Lambda is any real number. Okay. So I may write this as C1 into 1 minus cos lambda x, sorry, lambda pi minus C2 sin lambda pi equal to 0. Equation number 4, we'll call this. And we have another boundary condition which is for y dash. So let me first find derivative of equation 3. So I'll be having C1, negative C1 lambda sin lambda x, positive C2 lambda cos lambda x. Okay. And we again have y dash at 0 is equal to y dash at pi. So x की जगह 0 डालेंगे यहाँ पे. So we will have the first equation becoming C2 lambda. Okay. C1 will become 0 because of the sign term becoming 0 there. And when I put pi, I'll be left with negative C1 lambda sin lambda pi, positive C2 lambda cos lambda pi. Again, as case 2 says that lambda is not equal to 0, I'll divide by lambda. So I'll be left with C2 equal to negative C1 sin lambda pi plus C2 cos lambda pi. Okay, let's shift the terms on one side together. So you can shift it this side or that side, whichever way. So if I take C1 sine lambda pi plus C2 minus C2 cos lambda pi equal to 0. So I'll have C1 sine lambda pi plus C2 times 1 minus cos lambda pi. Matrix form, we'll write it. Equation number 4 and 5. So the coefficient of C1 is 1 minus cos lambda pi, negative sine lambda pi, sine lambda pi, and 1 minus cos lambda pi into C1, C2 equal to 0, 0. We want non-trivial solution. So for non-trivial solution, this determinant should be equal to what value, students? Yes, please. Should be equal to 0 or not equal to 0? Yes,
Equal to 0.
equal to 0. Yes. If it is not equal to 0, we will have only one solution, unique solution, which will be the 0 solution. Okay. So this should be equal to 0. So let's cross multiply. I'll have 1 minus cos lambda pi the whole square plus sine square lambda pi. This is equal to 0. So I'll have 1 minus 2 cos lambda pi plus cos square lambda pi plus sine square lambda pi equal to 0. The last two terms will give me a value 1. So 1 minus 2 cos lambda pi plus 1 is going to be 0. So this is going to be 2 minus 2 cos lambda pi equal to 0. Or I can say cos lambda pi will be equal to 1. Cos lambda pi giving me 1. When does cos theta give you 1? Yes, please. When does cos give you 1?
At
Pi by
n
2.
pi,
Sorry, at
n pi,
is it n pi or 2n pi?
Pi by 2.
Sorry, cos pi by 2 is 0.
Cos.
Cos pi by 2 is 0. Cos 0 is 1. Cos pi by 2
2
is
and
0.
pi.
2n pi, yes. Because cos
2n.
pi is negative 1. Okay. So this gives me 1 when it is 2n pi. So now cancelling out the required terms, I'll be left with lambda is equal to 2n. Lambda is equal to 2n, where of course n can belong to integers, or because we are working with, okay, you can say n belongs to integers. And this also covers the case of n equal to 0. So lambda equal to 0 isme aa chuka hai. Okay, even if you would have not done the case 1 separately, lambda equal to 0 is covered in this. I hope that is understood by everyone. And because cos is like a even function, I may just neglect this integers part and I may write only even numbers here. Because I have taken a separate one for negative 1 and cos is a negative even function. So even if you put a negative number, it's going to give me the final answer as positive. So lambda equal to 2n is going to work here. So these are your eigenvalues. And the corresponding eigenfunction, I'll get it from equation number 3. Correct? In equation number 3, I'll substitute 2n there. So that would give me C1 cos 2nx plus C2 sin 2nx. Now, as I said, see, previous questions, we were left with only sine or cos, okay? Not both. Here you're getting two answers. One is sine, one is cos, and both are linearly independent. So you will get multiple eigenfunctions here, and here you would get this is periodic boundary value problems. Okay, this is what happens in periodic boundary value problems. I hope things are clear with everyone. Any difficulties with the type of sums here? Yes, students. And of course, your reference book does have multiple more questions. Okay, you can see those questions, try. Maximum what is going to change is the boundary value questions. The boundary values will keep changing. So I think I showed you at least 3 different types of boundary values for the same type of problem. So it shouldn't be an issue. Is this fine with everyone? Clear?
Yes, ma'am.
Okay, fine. So we'll look at 2 more standard uh, functions which can be converted into Sturm Liouville problem, and then the method of Sturm Liouville can be applied to solve them. Okay, so those 2 equations are Basel's and Legendre's equations. Let's look at them. So Basel's equation, the standard form is x square y double dash plus xy dash plus x square minus b square y equal to 0. To bring it in the Sturm Liouville form, I would divide by x. Okay, so we are assuming x is non-zero. So I'll be left with x y double dash plus y dash plus x minus v square by x into y equal to 0. To bring it in the standard form of Sturm Liouville, observe these 2 terms here. Can I say this is nothing but d by dx of xy dash, the highlighted term, and this is the remaining part. Can I write it like this? Is that correct?
Yes, ma'am.
Okay, so is this in your form of d by dx of p of x times y dash q of x plus lambda times r of x into y equal to 0. So if you compare it, your p of x is equal to x, your q of x is equal to x again, and your r of x is equal to negative 1 by x. And all of these 3 functions are continuous. All of these 3 functions are continuous on real number line. Of course, you will have the condition that x is not equal to 0. Otherwise, the function r of x is not valid. Okay, so the Basel's problem can be converted into Sturm Liouville's problem, and the method of Sturm Liouville can be applied to Basel's equation to solve it. The next category of standard form you have is a Legendre's equation, which can again be converted into Sturm Liouville's problem. Okay, so let's look at the Legendre's equation standard form. It's 1 minus x square y double dash minus 2x y dash plus v into v plus 1 y equal to 0. Okay, how can you convert this into Sturm Liouville problem? The y term needs to remain as it is. The first 2 terms need to be combined as derivatives. Something into y dash. Correct, no? You require d by dx of some function into y dash. Plus the second part is going to remain the same. Come on, what will come in the bracket?
1 minus x square.
Very good, 1 minus x square, because 1 minus x square ka derivative is minus 2x. Correct, no? See, I said 1 minus, I wrote 1 plus. Okay, it's 1 minus x square into y dash, and yes, this gets converted into Sturm Liouville, where your p of x is 1 minus x square. Okay, your q of x is 1, your r of x is also 1, and your lambda is actually v into v plus 1, where v's are constants, over here. I hope things is clear over here. And in this case, lambda was negative v square. Lambda was negative v square. So I hope how to convert these standard problems into Sturm Liouville is clear. We will now understand the standard method of converting any second order differential equation into Sturm Liouville problem. Just a minute, the software. Okay, yeah. So the standard method or the general method to convert a second order or ODE. So any second order ODE, to convert it into Sturm Liouville problem, what are you expected to do? So let's assume the second order ODE, a naught of x, y double dash, a1 of x, y dash, plus a2 of x, y equal to 0. For this to be second order, a naught of x should not be equal to 0. Okay, you would multiply equation 1 to convert, okay? To convert equation 1 into Sturm Liouville problem, you multiply equation 1 throughout by nu of x. Now what is this nu of x? It is given by 1 upon a naught of x. A naught is non-zero. Exponential of integral of a1 of x divided by a naught of x dx. Okay, so when you multiply by this nu of x, your equation 1 will get converted to standard form of Sturm Liouville problem, and then you can apply the method of Sturm Liouville problem. Boundary value conditions, of course, will be given to you to solve it. I hope this is clear with all of you. Is this fine? We'll learn how to apply it with the help of examples, of course, but is this okay? Is the concept clear? Students, I appreciate it if you can unmute and say. Yes, please.
Yes, ma'am.
Okay. Thank you, Priyanka. Okay.
Ma'am,
Yes.
ma'am, sorry to take you back, but in legendary equation,
Mm-hmm.
qx, will it be equal to 1?
Sorry.
In the legendary equation,
Mm-hmm.
q of x, will it be equal to 1?
Yeah, because it's the function of x, no? There is no term of x over here with y, right?
Yeah,
It's a
ma'am.
stand. Correct, no?
So q of x should be 0, right, ma'am? Am I right?
Yes. Correct. Q of x would be 0. You're correct.
Okay,
Thank
okay.
you. Thank you.
Thank you, ma'am.
Yeah. So this would be 0. That's correction. Okay. Thank you. So qx is 0 and yeah, rx is 1. Perfect. Thank you. Okay. Getting back here. So before we start with some examples here, we'll understand the orthogonality. Okay. Now, before I get to orthogonality over here of eigenfunctions, let's understand we're getting various eigenfunctions. If you observe here itself, like every time you change the value of n and c1 and c2. Okay, this is one of the examples which we have solved. So एवरी टाइम n की वैल्यू आप जैसे जैसे चेंज करोगे या c1 c2 की वैल्यू चेंज करोगे आपको मल्टीपल आइगन फंक्शंस मिलेंगे यहाँ से करेक्ट इन द सेम मैनर हियर the previous one we got eigen functions here, so as you change the value of c2 you change the value of n, you will get multiple eigen functions. Okay, so we need to understand here when we take different eigenvalues. Okay, how will I get different eigenvalues here? Let's understand this. So you have lambda is equal to n square pi square, and corresponding eigenfunction, let me call it as yn because it depends on n, is c2 sin n pi x. So when I put n is equal to 1, say, my first eigenvalue is pi square. My first eigenvalue is pi square. Okay. And here I would get n is equal to 1, which gives me y1 of x is a family actually. C2 times sine pi x. Why is it a family? Because C2 की values जैसे जैसे change करोगे, you will get different values. Like this could be only sine pi x. It could be negative sine pi x. It could be any of these values, different values. Is that okay? And we will of course not take 0. We could have 2 sine pi x. We could have sine pi x by 3 and so on. Okay. So this is one family. Now if I take n is equal to 2, so I'll have lambda is equal to 4 pi square. And y2 of x would be equal to sine c2 times sine 2 pi x. Okay, another family of functions. Is that correct? Okay. So you would get some say sine 2 pi x. Then you will have negative sine 2 pi x and so on. You can have different values over here with respect to different C2s. Now these families here, which correspond to the different eigenvalues, will be orthogonal to each other. Okay. So these families like, sine pi x and sine 2 pi x, the family with negative sine pi x, you take any combination of functions from here, they will be orthogonal to each other. Now, what is orthogonal functions? When we talk about orthogonal functions as eigenfunctions, we need to first define that, and then we'll check the orthogonality over here. The main thing which you need to understand here is that the orthogonality condition comes in only for different eigenvalues, not for the same eigenvalue. So within the family, they are not orthogonal. So if I, okay, people are getting added now. Okay. Within the same family, they'll not be orthogonal, but for different eigenvalues, they will be orthogonal to each other. So first, let's understand what is this orthogonality when it comes to eigenfunctions. It's not exactly the same as orthogonality before we have defined. Okay. So we talk about orthogonal eigenfunctions. Okay. So let's understand this definition first, and then we'll look at some examples of orthogonal eigenfunctions as well. And of course, you will be able to check the orthogonality over there with the help of the examples which we have done as well. Okay. So we'll first look at the general definition. The functions say f of x and g of x are said to be orthogonal to each other with respect to the weight function r of x on the interval a comma b if integral a to b r of x into f of x into g of x with respect to dx turns out to be 0. So this is your condition for orthogonality. We say two functions are orthogonal with respect to the weight function r of x if this is a thing. Now let's understand the condition when it comes to SLPs. When you talk about SLPs, we say that corresponding to distinct eigenvalues, the eigenfunctions are orthogonal to each other with respect to the weight function capital R of x. Okay, so whatever different eigenvalues you will get, they're orthogonal to each other with respect to the capital R of x. So finding it in the standard form, finding capital R of x is important. So let's look at the examples which we have done here and try to check the orthogonality over there. So if we talk about the first example itself, I think this is the first one. Yeah, this is the first one. We had found R of x is 1 there, and we found the eigenvalues and eigenfunctions here. So let's check the orthogonality of these eigenvalues and functions here. Okay, I need to copy this. Okay. So different set of eigenvalues and eigenfunctions, which I brought it down from the previous question. Let's substitute the value of n here, and the property says for distinct eigenvalues. Okay, so we require at least 2 different eigenvalues. So let's start with n is equal to 0, the smallest number. N is equal to 0 will give me, say, lambda 1, the first eigenvalue, which will become pi square by 4l square. Okay, the corresponding eigenfunction here, say y1, would be c1 sine pi x by 2l. If I put n is equal to 2, I would have, sorry, n is equal to 1, I'll put. So that's going to be 3 square, which is 9 pi square by 4l square. The second eigenfunction would be, okay, this is c2, not c1. Fine, it's a constant, so not much to worry. Sine 3 pi x upon 2l.
मैम स्क्रीन बहुत स्लो चल रहा है.
Sorry?
I
Ma'am,
mean,
all
आप जो बोलते हो ना,
getting
तो
blank.
बाद में we can see
Screen
ऐसा.
is like becoming blank on and off, ma'am.
अच्छा, because यहाँ पे मुझे pause नहीं आ रहा है, 1 मिनट का भी pause नहीं आ रहा है. I don't know.
We can only see after a couple of seconds or so.
अच्छा, because last time when you all told me this last lecture में ऐसा कुछ हुआ था, but तभी मुझे टेक्निकल इश्यूज आ रहे थे और उसी टाइम पे वहां पे ब्लैंक जा रहा था. आज मुझे सच में कुछ टेक्निकल इश्यूज नहीं आ रहे हैं. ठीक है, I'll do one thing, I'll just close it and quickly start it again. Okay. Is the screen visible? Yes,
Yes,
please.
ma'am.
Okay, so अभी देखते हैं वो सेम टेक्निकल इशू आ रहा है कि नहीं आ रहा है. Okay, ये y1 y2 कैसे ढूंढा है, सबको समझ में आया है? Like I've just substituted the values of n, okay, for different values of n, and we're doing this because distinct eigen values के लिए ही हम orthogonality की बात करते हैं. And ये वाला जो क्वेश्चन हम बात कर रहे थे, यहाँ पे कैपिटल R of x हमारा 1 था. Okay, and इसमें of course I need to, yeah, 0 to l का लिमिट था हमारा, 0 to l था. So I need to check this integral between 0 to l of c2 square sine pi x by 2l into sine 3 pi x by 2l. So sin c into sin d का फॉर्मूला लगा देंगे यहाँ पे. Let me call this integral as I. So c2 square. I hope there is no delay in the screen now. Is the screen fine?
Yes, ma'am.
Okay.
Yes, ma'am.
चलो integration negative 1 by 2 0 to l Sine C into sine D is going to be cos C plus D. So when I add them, I'm going to get 4 pi x by 2l minus subtraction हो जाएगा, and cos में subtraction में negative sign फर्क नहीं पड़ता है, even function. So 2 pi x by 2l. Okay. So simplifying it a little more further, c2 squared divided by 2, 0 to l, cos 2 pi x by l and cos pi x by l. When I integrate, cos ka integral is sine. So this is going to be sine 2 pi x by l, the entire thing divided by 2 by pi in l, minus again l by 2 pi यहाँ पे भी आ जाएगा, साइन ऑफ नहीं l by pi आएगा, 2 pi नहीं आएगा यहाँ पे भी 2 pi मैं ऊपर लिख देती हूँ, साइन pi x by l. This is between the limit 0 to l. So when I put the limit l, so I will have the first term as sine 2 pi and second term हो जाएगा मेरा sine pi. लिमिट 0 डालेंगे तो दोनों टर्म 0 ही आने वाले हैं, and sin 2 pi and sin pi भी 0 है, तो ये पूरा टर्म आपका हो गया 0, which implies orthogonal. I hope this is clear with everyone. Okay, and this happens for distinct eigenvalues. Distinct eigenvalues के जो corresponding eigenfunctions होते हैं, they are orthogonal to each other with respect to the weight function capital R of x. Capital R of x is generally what we obtain from the question. Okay, so I'll give you one question where you need to try and find capital R of x on your own. So let's give it a try. I hope this is clear with everyone. The orthogonality part is understood. Yes, please. Hi, Anna.
Yes, ma'am.
Okay, fine. Thank you. So try this question. Okay. Find the weight function for which the eigenfunctions corresponding to distinct eigenvalues of the Sturm Liouville problem. Let me write it below. With the boundary condition y of 0 is equal to y of pi is equal to 0 are orthogonal. Come on, give it a try. You're expected to find the weight function for which the eigenfunctions will be orthogonal. Come on, try it. So what do you think should be the approach here? Will you first find eigenvalue and eigenfunctions and then calculate R of x, or how will you do it? Yes, please. क्या आपको यहाँ पे eigenvalues and eigenfunctions ढूंढने की जरूरत है? Yes, students?
Yes, ma'am. First, we have to find eigenvectors.
No, you don't require anything. Just find your R of x. R of x ऐसे ढूंढोगे आप?
Okay.
ये देखो, ये वाला जो हमें, ये देखो, ये जनरल वे टू कन्वर्ट अ सेकंड ऑर्डर ओडीई का है ना?
Yes, ma'am.
इससे आप म्यू ऑफ एक्स मिल जाएगा, इसको आप कन्वर्ट करो एसएलपी के स्टैंडर्ड फॉर्म में, आपको आर ऑफ एक्स मिल गया, आपको वेट फंक्शन ही तो पूछा है, उतना ही ढूंढना है.
Yes, yes, yes. Okay, okay.
Do it like that. You want me to show this formula? I hope you have noted down the formula. I'll go to the sum now.
Ma'am, mu x is e to the power minus 3x.
That's correct. R of x.
Okay.
No, mu x. Okay, you got mu x. Okay, then calculate R of x.
Yes, ma'am.
Yeah.
Yes, okay.
Then R of x is minus e raised to minus 3x.
Yeah, it's either negative or positive. आंसर आपको तो इंटीग्रेशन के बाद 0 ही आता है, तो you can take positive also or negative also, not an issue. Because इंटीग्रल का आंसर 0 आना है ना, तो आपका जो R of x होगा वो either negative हो या positive हो, कोई फर्क पड़ने वाला नहीं है. I hope that's clear with everyone. Does anyone want me to solve this entire sum or is it done? आपका a naught यहाँ पे 1 है, a1 of x is negative 3. Your formula for nu of x is 1 over a naught of x exponential of integral of a1 of x divided by a naught of x. So when I substitute the values, I have e raised to integral of minus 3 dx, which is nothing but e raised to negative 3x. And when I multiply equation number 1 throughout by this, I will have e raised to negative 3x d square y by dx square minus 3 raised to negative 3x dy by dx negative lambda e raised to negative 3x y equal to 0. the first two terms need to be converted into the standard form. Okay, anyway, the first two terms are going to give you P of x. Okay, so your interest, when you need to find R of x, your interest should be in the term which has y. So the y term here, okay, has a coefficient negative lambda times s, and whatever is multiplied with lambda is your R. So R of x here is negative e raised to negative 3x. So you can leave it at this, or even if someone gets a positive e raised to minus 3x, that's also okay. Because integration of negative term or integration of positive term, at the end, you want the answer to be 0. Okay? So I hope this question was clear with all of you. The question did not ask you to find the eigenvalues or eigenfunctions. It just asked you to find the weight function. Of course, they can ask you to verify. So if they ask you to verify, you will have to find the eigenvalues, you will have to find the eigenfunctions. Is this fine with all of you? Any
Yes,
difficulties
ma'am.
here? Okay, fine. So now there are a few properties of the Sturm Liouville problem. We will first list down those properties, and that completes your topic of Sturm Liouville or the eigenvalues, orthogonality, and eigenfunctions part. The remaining part, which is system of ODE, I'll take one more lecture, maybe tomorrow itself. Tomorrow, is it a holiday for all of you? Is it okay if I take it in the morning, or do you want me to take it in the evening? How do you want it? Like if it's a holiday for all of you, I can take it in the morning. If some of
Yes,
you are
ma'am. It's
working,
I mean,
convenient.
anytime is fine. Morning is also fine. So we are fine with this time as well.
okay, because what happens if we take it in the morning, everyone is free to utilize the entire day, kind of. That is why. So not very early, this fine. This timing, no one has issue with the working hours or something like that, right? Because it's a bank holiday. So I'll take it in the same time period. If there's any change, I'll let you know. Okay. So we'll first list down the properties of SLP, and we'll stop with this lecture.
Thank you. Please send the notes of this lecture as well.
Yeah, it will be uploaded. No, the YouTube link will be uploaded, so that will be available to you guys.
Sure. Thank you very much.
Yeah. So these are the results. So let's start with the SLP standard form. D by dx, P of x into y dash, Q of x lambda R of x into y equals to 0. This is true in some interval a comma b, where px, qx, rx are continuous functions. This is the necessary condition number 1, and this should be true for all x in the same interval. Condition number 2, px has continuous first order derivative. So the first order derivative of p of x should be continuous. Condition number 3, your p of x and r of x should be greater than 0. Again, for all x in the interval a comma b, with the boundary conditions a1 y of a2 y dash of a, where a1 square plus a2 square is non-zero. b1 y at b, b2 y dash at b equal to 0. Again, b1 square plus b2 square not equal to 0. So if lambda i's are eigenvalues and the corresponding eigenfunctions are phi i's, then the result number 1 all the eigenvalues can be arranged in an increasing sequence. So whatever values you get, lambda 1, lambda 2, and whatever, they can be arranged. They can be ordered. This is smaller than this is smaller than this, and so on. And it's an increasing sequence. Okay? So you would have something like lambda 1 less than lambda 2, less than lambda 3, and so on. So this is, of course, going to be a countable thing. This is, of course, going to be a countable thing. The second thing which you can do here with such initial conditions or such necessary conditions satisfied, corresponding to each lambda I, there exists a one parameter family of eigenfunctions. Now, what do you understand by this over here? Okay. This means, is there a lag on your part now in the video, the screen?
No.
Okay, because there's a technical error which I am facing here. Okay. This means any two eigenfunctions, okay, corresponding to same eigenvalue will be linearly dependent. Okay. We saw two distinct eigenvalues, whatever functions you get, they will be orthogonal. And if they correspond with the same eigenvalue, then they will be linearly dependent on each other. Okay. So this is what it means when we say one parameter function. The third outcome which we get here. Okay. Corresponding to the eigenvalue lambda n, the eigenfunction phi n will have exactly n minus 1 zeros in the interval a comma b. Now let's understand this with the help of an example. So of course go to the question which we have solved here. So let's not look at this one because it's a big calculation. Okay. I think this was 0 to 1, no? Yeah. So let's look at this particular example there. We had I'll take this there. Okay. So what does the statement claim? That for different eigenvalues, whatever is the corresponding function, it will have n minus 1 zeros in that particular interval. This interval which we were working over here was 0 to 1. The interval in which we were working over here was 0 to 1. So lambda equal to 1. So n is equal to 1. So lambda 1 will be pi square, and phi 1, the function over here, would be c2 times sine pi x. Okay, c2 times sine pi x. And lambda equal to 2, this function will become 4 pi square. Phi 2 will become c2 times sine 2 pi x. Now, just for our ease of calculation, this C2s and, as I said, they'll be linearly, this condition number 2 says, if we have same eigenvalue, they will all be linearly dependent. One parameter thing, if we say, so I can write this as sine pi x, considering C2 as 1, and considering C2 over here also as 1, I'll get sine 2 pi x. Okay, so we'll just look at this. Now look at the first function in the interval 0 to 1. In the interval 0 to 1. At 0, it will take the value 0. Okay. At 1, it will become sine pi. It will become sine pi. And sine pi we know is again 0. So what is happening to this function? In this interval from 0 to 1, how many times is it crossing the x-axis? How many times this sine pi x in the interval 0 to 1, is it crossing the x-axis? Yes, please. X-axis को कितनी बार से क्रॉस किया है? Is it crossing the
So what?
x-axis? Is it
2
crossing
times.
the x-axis? No, 0 to 1 open interval. Open interval. We're talking about open interval AB. Check that. Statement number 3 is open interval. Come on. Is it crossing x-axis? नहीं cross कर रहा है ना? तो 0 times, no?
No.
So यहाँ पे I can say the number of zeros is 0. यहाँ पे number of zeros की अगर बात करेंगे, तो first वाले केस में 0 है, and ये statement क्या बोल रहा है? n minus 1 zeros, no? n की value 1 थी हमारी. Lambda 1 was 1. Phi 1 is 1. तो n की value 1 है, तो 0 zeros आने चाहिए ना? Is that correct? Are you understanding this? अब phi 2 के लिए चेक करते हैं. phi 2 के लिए एज पर द थ्योरी ये कितनी बार क्रॉस होना चाहिए 0 to 1 में एक्स एक्सिस को? द नंबर ऑफ जीरो शुड बी 1, करेक्ट? n minus 1 यहाँ पे 1 होना चाहिए ना? ओके, तो यहाँ पे लेट्स पुट 0 and 1. तो 0 and 1 पे, इस पे जो ये 0 and 1 अगर डालोगे ना यहाँ पे, तो एक तो मिलेगा मुझे साइन 0 एंड दूसरा मिलेगा मुझे साइन 2 पाई एक्स की जगह डालोगे तो साइन 0 से लेकर साइन 2 पाई में ये पूरा साइकिल कंप्लीट करता है. यस और नो? तो ये एक बार इसको क्रॉस करता है and the number of zeros is 1. Is that correct? Are you understanding this? इसी तरह से if you keep changing your lambda, you will be able to calculate the number of times it is able to, and you don't need to even draw the graph. You can, with the help of result number 3, you can orally say how many times it will cross the x-axis. Number of zeros is nothing but number of times it crosses the x-axis. I hope things are clear. Any difficulties? Is this understood, students? Hi, Anna. You want me to explain? You want me to explain it again, or is it okay?
Can you explain it one more time, ma'am?
Yes. Okay. What does the property say? See, first property क्या बोल रहा है कि lambdas को हम increasing order में लगा सकते हैं. मतलब we can say, okay, this is lambda 1, this is lambda 2, this is lambda 3, and so on. ठीक है? So you can observe n की जगह जैसे जैसे values डालोगे वैसे lambda की value increasing order में जा रही है. Correct, no? I have taken this example from whatever we have solved. Example number 2 उठाया मैंने यहाँ से. तो n स्क्वायर पाई स्क्वायर, एग्जाम्पल 1 भी ले सकते थे बट वहां पे l था, तो आई डिड नॉट वांटेड टू डील विथ कॉन्स्टेंट्स। ऑलरेडी बहुत सारे कॉन्स्टेंट्स के साथ कर रहे हैं। आपको चाहिए तो एग्जाम्पल 1 भी चेक कर सकते हो, 3 भी चेक कर सकते हो, हमारे पास बहुत सारे एग्जाम्पल्स है। ओके, सो एग्जाम्पल नंबर 2 में जैसे जैसे n की वैल्यू चेंज करोगे वैसे वैसे लैम्बडा बढ़ते जा रहा है, लैम्बडा 1, लैम्बडा 2, लैम्बडा 3, यू कैन सी इट इज बिकमिंग अ इंक्रीजिंग सीक्वेंस। तो प्रॉपर्टी नंबर 1 भी यहाँ पे क्लियर होते जा रहा है आपके लिए। प्रॉपर्टी नंबर 1 में भी कोई डाउट नहीं होना चाहिए, हाँ या ना?
Yes.
प्रॉपर्टी नंबर 1 भी इस वाले एग्जाम्पल से प्रूव हो जा रहा है। प्रॉपर्टी नंबर 2 क्या बोल रहा है, यहाँ ये जो एग्जाम्पल लिया ना इसमें प्रॉपर्टी 1, प्रॉपर्टी 2, प्रॉपर्टी 3, हमारे पास टोटल 5 प्रॉपर्टी है, पांचों के पांचों क्लियर होने चाहिए। ठीक है, प्रॉपर्टी 1 क्लियर हो गया आपके लिए, कोई डाउट है वहां पे? ये इंक्रीजिंग ऑर्डर बनते जाएगा जैसे जैसे n की वैल्यू चेंज करते जाओगे। n की जगह 3 डालोगे तो 9 पाई स्क्वायर, देन 16 पाई स्क्वायर, 25 पाई स्क्वायर एंड सो ऑन। करेक्ट ना? n इज नेचुरल नंबर्स, तो हमारी जो n की वैल्यू जैसे जैसे डालते जाओगे वैसे लैम्बडा एक इंक्रीजिंग सीक्वेंस बनेगा। Agreed, everyone is clear with property number 1? Can I go ahead to the next one?
Yes, yes,
Yes,
miss.
ma'am.
Okay. What does property number 2 say? That eigenfunctions for the same eigenvalue, eigenfunctions corresponding to the same eigenvalue will be linearly dependent. Now look at only one of the eigenvalues. या तो लैम्बडा 1 ले लो, या तो लैम्बडा 2, या तो लैम्बडा 5, कोई भी एक लैम्बडा ले लो, कोई भी एक। चलो लैम्बडा 1 से अगर काम करना चाहते हैं हम, ठीक है, लैम्बडा 1 में मुझे मल्टीपल आइगन फंक्शंस मिल रहे हैं, ये अग्री है सबके लिए? मल्टीपल कैसे हो रहा है, C2 की वैल्यू चेंज करते जाओ तुम्हारे पास एक फैमिली ऑफ फंक्शंस बनते जाएगा। 5 जो है वो मेरा एक फैमिली है, 5 इज नॉट अ सिंगल फंक्शन, करेक्ट ना? ये फैमिली ऑफ फंक्शंस है ये वाला। जैसे जैसे C2 चेंज होगा वैसे यहाँ पे साइन पाई एक्स, साइन 2 टाइम्स साइन पाई एक्स, 3 टाइम्स आएगा, 4 टाइम्स आएगा, करेक्ट और नो? हाँ या ना?
Yes.
और ये जितने मल्टीपल्स है, अगर ये मल्टीपल है मतलब ये लीनियरली डिपेंडेंट होगा एक दूसरे पे।
Yes, ma'am.
ओके,
Yes.
तो अभी प्रॉपर्टी नंबर 2 भी क्लियर है,
Yes, ma'am.
प्रॉपर्टी 2 क्लियर है।
Yes.
Yes, miss.
ओके, अब प्रॉपर्टी नंबर 3 क्या बोल रहा है? प्रॉपर्टी नंबर 3 बोल रहा है कि जो लैम्बडा n लोगे उसके करस्पॉन्डिंग जो फाई n आता है उसके n माइनस 1 जीरोज होते हैं, मतलब लैम्बडा 1 के अगेंस्ट फाई 1 जो आएगा उसके 0 नंबर ऑफ जीरोज होंगे। जीरोज मतलब y ऑफ x बिकमिंग 0, इट क्रॉसिंग द x एक्सिस। ठीक है, उसका जो ग्राफ होगा वो x एक्सिस को उस पॉइंट पे क्रॉस करेगा। तो अगर फाई 1 को देख लो तो वो x एक्सिस को क्रॉस ही नहीं कर रहा है 0 to 1 में, ओपन इंटरवल 0 1 में, साइन पाई x है। ओके, आप इसमें अगर 2 sin pi x है जो भी लोगे ना, तो it will not cross your x axis even once. Others are all linearly dependent. Okay. Now if I talk about phi 2, it should cross the x axis one time. Is it crossing x axis one time? पाई पे क्रॉस करेगा ना, साइन 0 से लेकर साइन 2 पाई में साइन पाई पे भी वापस 0 बनता है ना वो वैल्यू। आर यू अंडरस्टैंडिंग? समझ में आ रहा है?
Yes,
आपका
yes.
जो क्लियर है? कंफ्यूजन है अभी भी? हाँ या ना? 0 और 1 की वजह से कंफ्यूजन हो रहा है?
Yes,
आपका
ma'am.
साइन का जो कर्व होता है वो आइडियली ऐसे मूव करता है, राइट? साइन 0, साइन पाई, साइन
Yes,
2
ma'am.
पाई। ओके, अब ये वाले जो वैल्यूज है ये आपके x की वजह से चेंज हो रहे हैं ना। यहाँ पे x जब आप 0 और 1 डालते हो, तो जब फाई 2 में मैंने 0 और 1 डाल दिया, ओके, फाई 2 में साइन 0, फाई 2 एट 0 कैलकुलेट किया एंड फाई 2 एट 1 कैलकुलेट किया, तो फाई 2 मेरा साइन 2 पाई x है, तो 2 पाई 0 मतलब साइन 0 हो जाएगा एंड 2 पाई 1 मतलब साइन 2 पाई हो जाएगा। मतलब मेरा ये वाला ग्राफ है, तो ये जो वैल्यू है, एक मिनट, हाँ, ब्लैंक हुई थी स्क्रीन आपकी।
No, ma'am, it's visible.
हाँ, आई डोंट नो, मेरा वो पेन सिलेक्ट नहीं हो पा रहा है। ओके, सो ये वैल्यू 0 पे है एंड ये वैल्यू x इज इक्वल टू 1 पे है। आर यू गेटिंग? ये जो 2 पाई है वो x इज इक्वल टू 1 की वैल्यू है एंड दिस इज एट x इज इक्वल टू 0। इन द केस ऑफ फाई 1, you were between 0 and pi. This was at x is equal to 0 and x is equal to 1. तो ये एक भी बार x axis को क्रॉस नहीं कर रहा था, तो 0 number of zeros, which is also by theory, and ये एक बार क्रॉस कर रहा है, तो 1 number of zeros is also by theory. Are you understanding? समझ में आ रहा है?
Yes, ma'am.
Okay, everyone is clear. So this is property number 1, 2 and 3. और दो properties हैं, उसमें से एक तो हमने already देख ली है. Okay, तो property number 4, corresponding to distinct eigenvalues, the eigenfunctions are linearly independent. So same eigenvalues वाले linearly dependent है और distinct eigenvalues वाले linearly independent है. And the last property, again corresponding to distinct eigenvalues. Okay, corresponding to distinct eigenvalues. The eigenfunctions are orthogonal with respect to the weight function capital R of x. Capital R of x. I hope all the 5 properties are clear now with everyone. These are the properties of SLP. Any difficulties in understanding the Sturm Liouville problem? Orthogonality, the weight function, how to convert the Bessel's equation into the Sturm Liouville, how to convert the Legendre's into the Sturm Liouville. Is everyone clear? Yes, please. Any doubts? आज का लेक्चर समझ में आया है सबको? Yes or no?
Yes, ma'am.
Yes,
Okay.
ma'am.
Yeah. So next lecture, we will be moving on to the last topic, that is a system of ODE. Okay. वहाँ पे भी again eigen values and eigen vectors पे deal करेंगे, not eigen functions. We will be dealing with eigen values and eigen vectors over there, and that's your last topic of ODE. I hope this lectures are going to help you prepare for your exams. All the very best. Okay, I'll be uploading the video and I'll share the link then. Thank you, class. You can leave.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.